Hello, National 5 chemists. I hope you're all doing really well and ready for some more Unit 3. Today we're going to have a look at redox. Now, a redox reaction in chemistry is comprised of both a reduction and an oxidation reaction. So in order for us to understand what redox is, we're going to have to understand first of all what reduction means and what oxidation means. So reduction then, well, reduction is the gain of electrons. So if in a chemical reaction something is gaining electrons, it is being reduced, or it's a reduction reaction. Now that might seem back to front to you. You might be thinking initially, if you're reducing something, if something's a reduction reaction, surely it would be losing, not gaining. But unfortunately, that is the case in chemistry here. What we're talking about, reduction reactions, are the gain of electrons. And therefore, what's an oxidation reaction? Well, it's the opposite of that. Oxidation reactions, that is the loss of electrons. So we've got two different types of reactions here. A reduction reaction, which is the gain of electrons, and an oxidation reaction, which is the loss of electrons. And together, they form redox reactions. And that's where the name comes from. Red comes from reduction, oxidation. And it makes sense that they would occur together, because if something is to gain electrons, it's going to have to gain them from somewhere. So something else has to lose the electrons. So they occur in tandem and parallel with each other. Wherever you get oxidation, you get reduction, and vice versa. Now that can be a little bit confusing to learn, right? In terms of reduction is gain and oxidation is loss. Nice way to remember it is if we remember the word oil rig, one of these things that you find out in the North Sea to drill for oil. Oil rig is a nice little way that we can remember the correct definitions of these reactions. So O is oxidation, I is loss. So oil rig, the first part, oil, oxidation is the loss of electrons, where reduction, the rig part, well, that is the gain of electrons. Now, if we remember oil rig, we should remember these two reactions. And as I've said, these two reactions always occur together. If you have an oxidation reaction, you also have a reduction reaction. Now, you are all very familiar with the data booklet, and you've probably, when you're leafing through it, have seen this page before. It's the very last page, page number 10, and we have this, I suppose it's like a league table of different metals, with our most reactive metals at the top and our least reactive metals at the bottom. This is called the electrochemical series, and within the table we have got all of these little reactions, sometimes called half reactions, and they are all an example of reduction reactions. Every single one of these reactions is a reduction. Remember to what we said earlier, oil rig, oxidation is loss, reduction is gain. So all of these chemicals are gaining electrons. And let's just check that. I've got lithium positive ion plus an electron, gaining an electron, becoming the lithium atom. Next one, potassium positive ion, gaining an electron, becoming the potassium atom. So these are all reduction reactions, and they're all gaining electrons. If I'm ever asked to write down a reduction reaction in my National 5 chemistry test or exam, I should go to this page and just copy down exactly what is said. So if you were asked, for instance, to write down the reduction reaction for sodium, I would go to this page, page 10 of the data booklet, go down to sodium and write down Na positive plus an electron. It's a reduction reaction, so it's going to be gaining electrons, turns into Na, the atom. And it's as simple as that if I need to write down a reduction. For an oxidation though, if I was asked to write an oxidation reaction instead of a reduction reaction, well, I don't have a page in the data booklet for the oxidation reactions. They're only reductions here. So to write an oxidation this time, instead, what I would have to do is to find the element I'm looking for and write the equation in reverse, flip it round. So I'll show you an example of that. Let's say I was asked to write down the oxidation for, I don't know, let's go for aluminium. I wanted to write down the oxidation reaction for aluminium. I would go down, find aluminium. I can't write it exactly as it is here because that would be the reduction reaction. So in order to write the oxidation reaction, I just write the equation in reverse. So I start with the product and write that on my reactant side, so Al, and then I put my arrow and I write this part, Al3 plus 3 electrons, and now I've written the oxidation reaction for aluminium. So it's that easy. Reduction reaction, you just write it exactly as it is. For an oxidation reaction, we just reverse or flip the equation. And I can always double check to see if I've done it right if I remember oil rig. I was asked to write down an oxidation for aluminium, so oxidation is the loss of electrons. Let's check it out. I've got aluminium as my reactant, turning into the Al3 plus ion by losing 3 electrons. So that aluminium has broken down into Al3 plus, and it has also lost 3 electrons to do so. Okay, I've done it right. And the same with the reductions. Reduction should be gaining the electrons. Let's look at this example question now. It's asking us to write out the oxidation and reduction half equations for magnesium reacting with oxygen. First thing I'm going to want to do here is to write out my balanced chemical equation. Let's start out with a word equation first of all. So I've got magnesium, and I'm going to react that with oxygen. We should be more than comfortable by now with working out the product here. If I react a metal and oxygen, I produce a metal oxide, and in this case the metal oxide will be magnesium oxide. Now I'm going to want to write out my ionic equation to look at the charges. It's very important when trying to determine if something's been oxidized or reduced is to write out the ionic equation. Remember, not everything gets charges, it's only the ionic compounds. So I've got Mg for magnesium plus O2 for oxygen, and that's going to give me MgO for magnesium oxide. Let's quickly balance this equation by putting in a little half in front of the O2. Now I've still not written out my ionic equation. I need to put in the charges where relevant. Magnesium has metallic bonding and no ionic charges need to be put in there. Oxygen, two non-metal elements joined together, well that's covalent bonded, and over here I've got magnesium oxide. Now that is ionically bonded, so that does need to get charges. Magnesium's a metal in group 2, so it's 2 plus, and oxygen's a non-metal in group 6, so it's 2 negative. So let's go back to the question and just remind ourselves what it's been asked it asked us to do. Write out the oxidation and reduction half equations for magnesium reacting with oxygen. I need to figure out what is being oxidized and what is being reduced. Let's quickly remind ourselves about oxidation and reduction. Oxidation is the loss of electrons and reduction is the gain of electrons. Let's focus in on the magnesium first of all. On the left hand side it is the magnesium atom with effectively a charge of 0. It's neutrally charged. If I look at it over on the right hand side now, it has become too positively charged. It is a metal Metals always lose electrons. It's become positively charged. How has it gone from magnesium, the atom, to magnesium, the 2 plus ion? Well, it must have lost 2 electrons. If something's losing electrons, something else is gaining them. So let's have a look to see who's gaining electrons. Here's my oxygen atom on the left hand side. There it is on the right hand side. Over here it has no charge. Over on the right hand side now it has a charge of -2. Well, how has it done that? It must have gained 2 electrons from the magnesium. The magnesium lost 2 electrons and gave them to the oxygen, which gained 2 electrons. So remember, the question asked me to write out the half equations for the oxidation step and the reduction step in this reaction. I've already determined that magnesium is being oxidized, it's losing electrons, and oxygen is being reduced, it's gaining electrons. So let's have a go at writing out those half equations now. So let's start off with the oxidation step. Oxidation. And we've already said that, well, it's the magnesium that is being oxidized. Oxidation is the loss of electrons. So the magnesium is turning into the Mg2 plus ion by losing 2 electrons. Now you can do that exactly like I've done there and just kind of figure it out based upon what's happening to the magnesium. Or you could just go to page number 10 in the data booklet, find magnesium, and then to write the oxidation reaction, I just write that equation in reverse like I've done here, and we'll get the exact same answer. For the reduction step, again, I can just go to page number 10, find the correct equation and just write it as is. I don't need to do anything to it for a reduction reaction. I just write it exactly how it is in the data booklet, but for an oxidation, I reverse it, I flip it round. For our reduction reaction here, I've got oxygen reacting into the O2 negative ion by gaining 2 electrons. So let's have a look here. I have got O2 that is gaining 2 electrons and turning into the O2 negative ion, and I'll put an extra little 2 here just to balance it to make sure that we've got 2 oxygens on both sides. And there's a reduction step for this reaction. Remember, oxidation is the loss of electrons, reduction, the gain of electrons. Okay, let's look at a couple of different styles of questions here. This one's saying use page 10 in the data booklet to write the ion-electron equation for each of the following reactions. So page 10 in our data booklet looks like this. It's our electrochemical series, and ion-electron equation, that's just these little half equations here. So all of these ones are reductions. If it's asked us to write out a reduction reaction, just write it as is. If it's an oxidation, like it is for part A, then I go down the list, I find the one I want to write, and I just write it in reverse. Al going to Al 3 plus 3 electrons. I've just written this equation in reverse, and there's the oxidation for aluminium. Part B, asking me to write a reduction. Easy. I go down, find zinc. There it is there, and I write it out exactly as it is. All of these reactions are already reduction reactions. I don't need to do anything with them. I just write them as is, and I'm done. This time I've got 3 questions here where it's asking me to decide which one of these is going to be an oxidation or a reduction reaction. Now let's not forget our handy little help. Oil rig, oxidation is loss, reduction is gain. Let's check out what's happening in part A. I'm starting with copper 2 plus, and it's turning into just copper. How is it doing that? Well, it's gaining 2 electrons. Those 2 electrons are cancelling out the 2 positive charge of the copper ion. It's gaining electrons. The gain of electrons is reduction. So part A is a reduction. Let's look at part B. Similar story here. I'm going from Br to Br negative. How is it doing that? Well, it's gaining negative electrons. The gain of electrons is reduction. Third one, aluminium going to aluminium 3 plus 3 electrons. It's losing the electrons. We've seen this one before now. It is an oxidation reaction because the aluminium is losing its electrons. And the last couple of examples we're going to have a look at is trying to look at a more complicated example where we have an ionic equation and we've been asked to spot who is being oxidized and who is being reduced. Now I recommend just looking at each individual atom and ion individually and seeing what's happening to them over the course of the reaction. First of all, I've got calcium, which is turning into the calcium 2 plus ion. It's becoming positive. It must be losing negatives. The calcium is losing or has lost 2 electrons. Therefore, as we know, oxidation is the loss, reduction is the gain. So in part A, who's being oxidized? Part A, oxidized. That is our calcium, and the calcium is turning into the calcium 2 plus ion by losing 2 electrons. Let's continue to look at part A and see who's being reduced. I've got the nickel 2 plus ions on this side, and I've got nickel with no charge on the right hand side. Well, how has nickel done that? How has it got rid of that positive charge? It must have gained negative charges. It must have gained 2 negative electrons. So the reduction of nickel, remember I can just go to page 10 and copy this out. I don't have to try and curate it like I'm doing here. Just go straight to page 10, you'll find this half equation and just copy out exactly how it is for the reduction step. Let's check the last element in this reaction. I've got chlorine on the left hand side, Cl negative, chlorine on the right hand side, Cl negative. This is a spectator ion. Nothing's happening into it. It's undergone no change in charge, undergone no change in state. It's not really taking part in the reaction. Okay, let's look at part B here, and again let's figure out who is being oxidized first of all, and then see who is being reduced. Chlorine on the left hand side is the chlorine neutral atom. It has no charge. However, when it's across onto, use a different colour. When it's across, onto the product side, it has changed. It has become the chlorine negative ion. It's gained negative charge. It must have gained an electron. Remember, reduction is the gain of electrons. So if I want to write out the reduction of chlorine, go to page 10 of the data booklet and write it out exactly as it says. Cl 2 plus 2 electrons is giving me 2 Cl negative. This is being reduced because it is gaining electrons. Let's look at the potassium now. Potassium is K plus on this side, is K plus on that side. It's also aqueous on both sides. Nothing's happened to the potassium. It's a spectator ion. It's not taking part in the reaction. It is neither being oxidized nor reduced. And lastly, I've got my bromine going from Br1 negative to Br2, which is neutral. Well, that must have lost negative charge, must have lost electrons, And again, I can go to page 10 of the data booklet to write out the oxidation. I just flip it. And so I would write 2Br negative turning into Br, the diatomic molecule, by losing 2 negative electrons.